SpaceX just fired up Booster 15 for what could be the final Block 2 static test ever, and Flight 11 is targeting October launch. This marks the end of an era before Block 3 takes over completely. But here's what's fascinating. Why rush this last Block 2 mission when they're so close to next-gen vehicles? The answer reveals SpaceX's bigger strategy that most are missing. We'll unpack the real timeline, what makes this final Block 2 flight critical, and why October could be make or break for Starship's evolution. Booster 15's static fire wasn't just another test. It was a 70-meter-tall farewell to an entire generation of Starship technology. Standing roughly the height of a 20-story building, this massive booster represents the culmination of everything SpaceX learned from their early Starship flights. But here's what few people realize. This wasn't supposed to be the last Block 2 booster at all. The engineering challenge SpaceX faced was unprecedented. Think of it like upgrading from a prototype sports car to a production model while you're still racing the prototype. They had to keep Block 2 operational while simultaneously developing Block 3, a completely different beast that requires new launch infrastructure. The static fire process alone reveals the complexity. Over 30 minutes of cryogenic propellant loading, with liquid methane and oxygen flowing through systems that must operate at temperatures of minus 162 degrees Celsius that would freeze most materials solid. What makes this particularly fascinating is the infrastructure gymnastics SpaceX performed. They literally had to invent temporary components, the quick disconnect adapter and launch mount adapter, just to test Ship 38 on Pad 1. It's like building a custom bridge just to move one last car across a river before demolishing the old road. These makeshift solutions took enormous engineering effort for what amounts to maybe 2 uses total. And here's what most engineers don't appreciate. Creating temporary hardware that can handle the extreme forces of Raptor engines is arguably harder than building permanent solutions. The technical specifications tell the real story. Booster 15 has already flown on Flight Test 8, making it only the second Super Heavy to ever be reflown. Those scorch marks visible on its top section? They're battle scars from reaching the edge of space at velocities exceeding 1,600 miles per hour. Meanwhile, Ship 38 features the revolutionary crunch wrap heat shield design, essentially white cloth cutouts that wrap around tiles to fill gaps and prevent the 1,400 degrees Celsius heat of re-entry from seeping through to the vehicle's structure. And here's the detail most people overlook. SpaceX refers to these heat shield improvements by the oddly casual name crunch wraps, like the Taco Bell item. But don't let the playful naming fool you. Bill Gerstenmaier, SpaceX's VP of Build and Flight Reliability, confirmed these improvements led to the heat shield on Flight 10 staying almost entirely attached. A massive leap forward from earlier flights where tiles scattered like confetti during the landing flip maneuver. The timeline itself reveals SpaceX's extraordinary pace. Just 10 days after Flight 10, Booster 15 was rolling out for static fire testing. To put this in perspective, NASA's Space Shuttle program required months between flights, and even SpaceX's own Falcon Heavy takes weeks to prepare between missions. But there's something even more remarkable happening. While conducting these rapid tests, SpaceX simultaneously removed all 20 booster hold-down clamps and installed ship-specific hardware, essentially reconfiguring their launch infrastructure in real time. The logistics alone are staggering. Moving a 70-meter booster requires precise choreography. Watch the grid fins rotate as it enters Mega Bay 1. That's not just for show. Those fins must be positioned perfectly to avoid collision with the bay entrance, then rotated back for storage. It's like parking a skyscraper in a garage, except the skyscraper has been to space and back. But this is just the beginning. What's really surprising is how this final mission reveals SpaceX's broader strategy that nobody else in the industry is attempting. While everyone's focused on Block 2 ending, SpaceX is actually orchestrating a calculated transition that positions them years ahead of competitors. This isn't just about retiring old technology, it's about maintaining launch momentum while upgrading their entire operational foundation. And here's what few people realize. This transition strategy is so aggressive that it's forcing every other space company to reconsider their development timelines. Consider the competitive landscape in stark numbers. Blue Origin's New Glenn has been in development for over a decade and still hasn't flown. NASA's SLS costs $4.1 billion per launch and requires 18 to 24 months between missions. ULA's Vulcan has managed 2 flights in 2 years. Meanwhile, SpaceX is conducting static fires just 10 days after their previous flight. That's not just fast, it's redefining what operational means in heavy-lift spaceflight. The October timeline for Flight 11 represents something no other company has achieved: rapid iteration on the world's most powerful rocket. But there's an economic dimension here that changes everything. The $17 billion Starlink EchoStar deal announced this week isn't coincidental timing. SpaceX needs massive satellite deployment capability, and Starship is the only vehicle that can deliver it economically. Each Starship can carry roughly 400 satellites versus Falcon 9's typical 23. That's nearly 17 times the capacity. And here's what the math reveals. At current Falcon 9 launch costs, deploying Starlink's planned 42,000 satellites would cost over $50 billion in launch services alone. Starship makes this economically viable. The infrastructure investments reveal the scale of SpaceX's ambition. Pad 2 construction is progressing at breakneck speed with new flame trench designs, electrical systems already being routed, and bunker shielding installation. The air separation unit being built is significantly larger than initially anticipated, because they're not just planning for test flights, they're building for industrial-scale operations that could support dozens of launches per month. This leads to a remarkable discovery. SpaceX is essentially building a rocket factory and spaceport simultaneously, something no space company has ever attempted at this scale. Meanwhile, the reconstruction at the Massey's test site shows how seriously they take iterative improvement. After Ship 36's explosive finale in June damaged the flame diverter, they're not just repairing, they're methodically upgrading individual pipes in the flame trench. It's like rebuilding a race car engine while the race is still happening, making it better each time. But here's what's truly noteworthy. They've maintained their testing schedule throughout this reconstruction, demonstrating operational resilience that their competitors simply don't possess. The regulatory environment adds another layer of complexity. The FAA recently approved doubling Falcon 9's launch frequency from SLC 40 to 120 flights per year. That's unprecedented regulatory support, but it also signals something bigger. Government agencies are preparing for a world where SpaceX launches become routine, not exceptional events. And here's the strategic implication. When Block 3 becomes operational, SpaceX won't just have better rockets. They'll have regulatory pathways that took years to establish. There's also a human element often overlooked. The teams running these operations are gaining experience that money can't buy. Every static fire, every transport operation, every integration sequence builds institutional knowledge. While competitors are still figuring out how to reach orbit reliably, SpaceX's teams are mastering the choreography of rapid heavy-lift operations. And here's why this changes everything. SpaceX isn't just transitioning to Block 3 for better performance. They're transitioning to a completely different operational model where Starship becomes as routine as Falcon 9 is today, except with 100 times the payload capacity. Flight 11 represents the last time we'll see the pioneering Block 2 design fly, but it's opening the door to capabilities that will fundamentally reshape human space access. The Block 3 vehicles waiting in the wings aren't just improvements. They're the foundation for SpaceX's Mars architecture, lunar operations, and a space-based economy that could dwarf anything we've seen before. Here's what the timeline reveals about SpaceX's master plan. Block 3's first flight is pushed to next year, but that delay is actually strategic. SpaceX is using every Block 2 flight to validate systems that Block 3 will inherit. The heat shield improvements, the landing techniques, the operational procedures. All of this becomes the baseline for vehicles designed to carry humans to Mars and deploy satellite constellations that could number in the hundreds of thousands. But there's a detail most people overlook. Each successful Block 2 flight reduces the technical risk for Block 3 by orders of magnitude. The infrastructure transition reveals unprecedented ambition. Converting Pad 1 to the same flame trench design as Pad 2 means SpaceX will eventually have two fully operational Block 3 launch sites. That's not just redundancy, it's the foundation for the kind of launch cadence that makes Mars colonization economically feasible. Think about it. If SpaceX can launch Starship every few days from each pad, they could theoretically support continuous cargo runs to Mars during optimal transfer windows. And here's what's truly noteworthy. They're building this capability while their competitors are still struggling to reach orbit reliably. The economic implications are staggering. Current estimates suggest that establishing a permanent Mars settlement would require transporting roughly 1 million tons of cargo and equipment. With traditional rockets, this would cost trillions of dollars and take centuries. Starship could potentially reduce these costs by 99% and compress the timeline to decades. But here's what happens if SpaceX succeeds. They don't just enable Mars colonization, they create the first truly space-based civilization. The challenges ahead are significant, though, and SpaceX isn't sugarcoating them. Block 3 vehicles are heavier, more complex, and require completely new ground systems. The catch mechanism that worked for Block 2 boosters will need fundamental modifications for the upgraded vehicles. The thermal protection systems must handle longer missions and multiple re-entries. SpaceX is essentially rebuilding Starship from the ground up while maintaining operational tempo, a risk that could slow progress if anything goes wrong during this transition. Yet this is precisely why October's Flight 11 is so critical. It's not just the Block 2 finale. It's the validation flight that gives SpaceX confidence to fully commit to Block 3 production. Every successful Block 2 flight reduces the risk profile for the next generation. What happens if Flight 11 encounters problems? SpaceX has backup boosters, like Booster 17 in the Rocket Garden, but delays could cascade into Block 3 development timelines, potentially pushing Mars mission objectives back by years. The ripple effects extend far beyond SpaceX. When Block 3 becomes operational, it will force every other space company to reconsider their strategies. NASA's Artemis program could accelerate dramatically with reliable heavy lift capability. Commercial satellite operators might redesign entire constellations around Starship's massive payload bay. Even national space agencies will need to adapt to a world where super heavy lift capability is routine and affordable. Perhaps most significantly, this transition represents something unprecedented in aerospace history. A company evolving its most powerful rocket in real time while maintaining operational capability. Boeing spent decades developing the 747. NASA took nearly a decade to develop the space shuttle. SpaceX is iterating Starship in months, not years. As we stand at this transition moment, Flight 11 isn't just ending Block 2's story, it's beginning the chapter where Starship transforms from experimental vehicle to the backbone of humanity's expansion into space, making science fiction into operational reality. This is exactly why SpaceX's aggressive Block 2 timeline makes perfect sense. They're not just retiring old technology, they're compressing decades of aerospace development into months. While other companies spend years perfecting single vehicles, SpaceX is mastering the art of rapid rocket evolution itself. That October launch isn't the end of an era. It's proof that iterative development can outpace traditional aerospace timelines. What this means for space exploration is profound. We're witnessing the transition from rockets as rare, precious vehicles to rockets as industrial tools. When Block 3 becomes operational next year, humanity will have routine access to capabilities that make Mars missions, lunar bases, and massive space infrastructure not just possible, but inevitable. And this is just the beginning. Block 3's first flight, Pad 2's completion, and the orbital missions starting with Flight 13, each milestone builds towards something unprecedented, a truly spacefaring civilization. The next 18 months will determine whether SpaceX's vision becomes reality or ambitious overreach. How do you think this Block 2 to Block 3 transition will change the timeline for Mars missions? Are we looking at 2028 launches to Mars, or will the complexity of Block 3 push those dreams further out? This is Space Hub, where we break down the engineering and strategy behind humanity's greatest space achievements. If you want to understand not just what's happening in space, but why it matters for our future, you know where to find the deep analysis. We're not just watching rockets evolve, we're witnessing the birth of humanity's expansion beyond Earth. Russia's worst nightmare just became reality. For the first time ever, SpaceX's Dragon has stolen control of the ISS's most critical function, orbital boosting, ending Moscow's 20-year monopoly over keeping the station alive. This September 3rd breakthrough doesn't just free NASA from Russian dependency, it signals the complete end of Russia's leverage over American space operations. But there's something even bigger happening that no one's talking about. Why is SpaceX really mastering this technology when the ISS dies in 2030? The answer reveals their master plan to dominate the entire future of space stations, starting with Vast Haven. Today we're exposing how this single reboost test just broke Russia's space control forever. September 3rd, 2024. For exactly 5 minutes and 12 seconds, Russia watched their 20-year monopoly over ISS orbital control crumble in real time. SpaceX's Dragon wasn't just performing another test, it was executing the most significant power shift in space operations since the Cold War. Here's what actually happened during those critical minutes. Dragon fired its newly upgraded Draco thrusters in a precisely calculated burn, lifting the entire 420-ton International Space Station by 1.6 kilometers. But here's what the headlines missed. This wasn't just about altitude. This was about breaking Russia's stranglehold over the most critical function keeping the ISS alive. Think of the ISS as a massive cruise ship constantly sliding down an invisible hill. Earth's atmosphere, even 400 kilometers up, creates enough drag to pull the station down 50 to 200 meters every single day. During solar maximum periods like we're experiencing now in solar cycle 25, that drag intensifies dramatically. Without regular orbital boosts, the ISS would lose 20 to 50 kilometers of altitude annually, eventually spiraling into catastrophic re-entry. For over 2 decades, only Russia's Progress spacecraft could perform this life-or-death task. Moscow held the ultimate trump card. Walk away from the ISS, and NASA loses the ability to keep their $150 billion investment from becoming space debris. Russia's Progress could manage 1 or 2 burns per